Hi everyone, I welcome you all in the third lecture of ethanol production. So in previous lecture, we have seen that what is engines knocking and how engines knocking occurs inside a petrol engine or any kind of engine. And we have seen that due to auto ignition inside the engine, due to the generation of free radicals, that is a very small molecules, uh, and if you compress more, these free radicals, then definitely it gets auto ignited, and due to this auto ignition, the two spark molecules collides inside the engine, and that basically creates a noise, and that is called as a knocking or detonation. And then we have also, answered what is octane number and what are the octane numbers for various fuels. And then we have also seen that how basically octane number is being calculated. And we have also defined two kinds of octane number. That was, research octane number that is basically displayed in India on petrol pump. And then there is a motor octane number having and both of these octane number has been calculated in different conditions. So in today's lecture, we are going to answer two very interesting questions. That is, why does ethanol have such a high octane number, and why does ethanol have a high heat of vaporization? So at the end of this lecture, you will be able to answer both of these questions. So let's try to understand this question first. So first I'll answer about why does ethanol have such a high octane number. So in order to understand these things, we should understand first what is something that is special in the chemical structure of ethanol. And if you see the chemical formula of ethanol, you will see there is oxygen that is connected with this carbon. That means there is alcoholic group present in the ethanol. And this oxygen is very important. That will basically tell you why ethanol is having higher octane number and why ethanol is having higher heat of vaporization. So, so if we see the structure of the ethanol that contains oxygen atom, but that is not there in the petrol molecules. Petrol molecules are a mixture of hydrocarbons and that are connected with the weak van der Waals forces of attraction, that is London and dispersion forces. So the oxygen molecules or the oxygen atom in the ethanol helps the combustion process in a more controlled manner once ignition occurs. So it is not the direct reason for the higher octane number, but that contains, that can, facilitate the clean combustion inside the engine. So the first answer of this question is the oxygen molecules. So due to these oxygen molecules that facilitates the, cleaner combustion that generates lower carbon monoxide emission that is not there in case of regular petrol, and that contains fewer unburned hydrocarbon. Then coming to the second reason, that is ethanol is having resistance for the auto ignition. As we have seen in the previous lecture, that if a molecule or if a fuel is having auto ignition characteristics, then that fuel will be having a lower octane number and that will generate more noise and that will show less resistance for the anti-knocking, sorry, knocking. But when we talk about the ethanol, if you see the molecules of petrol that during the compression, what happens that generates various free radicals like H free radicals, OH free radicals, you know, CS3 dot free radicals during the or and that basically creates the auto ignition. But when we talk about the ethanol molecule is having OH group that changes the decomposition pathway. And this is having the less tendency to form uncontrolled radical, and that will wait for the spark ignition. So there won't be any auto ignition takes place in case of ethanol molecules, and that basically resists the auto ignition. And third, and that is very important point for this discussion, that is a high heat of vaporization. So ethanol, if you see the ethanol molecules are connected with the hydrogen bond having, site for the hydrogen. So if you see these molecules, oxygen is having higher electronegativity. So this oxygen basically attract the electron cloud of this hydrogen, and over which you will see there is a partial negative charge on the oxygen and there is a partial positive charge over the hydrogen. And due to this particular region, the ethanol molecules are connected with the hydrogen bond with another molecules. Right. So due to this hydrogen bond, what happens? That hydrogen bond requires higher energy to break compared to the weak van der Waals forces of attraction like London and dispersion forces. And if we compare the, heat of vaporization of fuels like petrol and ethanol. So in case of petrol, because as I told you, the hydrocarbons molecules are connected with weak hydrogen bond, that requires only 350 kilojoule per kg of heat to get vaporized, but ethanol molecules require 840 kilojoule per kg of the heat to get vaporized. So if you see that the ethanol is having two times more heat of vaporization compared to the petrol. So if we, understand with the simple analogies, like petrol is like a dry paper that catches fire very easily and that is having higher knocking characteristics. But when we talk about the ethanol, it's like a slightly damp wood that absorbs heat first and after that, that will start burning. So that does not contain any knocking because that resists the knocking. Right. Now, in a summary, we can say that when ethanol is having higher heat of vaporization and that resists the auto ignition and that also resists the radical that contains the chain reaction, like that suppresses the uncontrolled reaction before a spark. And ethanol molecule contains oxygen atoms and that promotes the clean and complete combustion after ignition. And that is why you will see this is the reason that's why ethanol is having higher octane number. Octane number is just how much resistance of fluid is about the knocking tendency. And if all of these characteristics are there, that will resist the noise, and that's why ethanol will be having a higher octane number. Now, coming to the next question, that is why does ethanol have higher heat of vaporization? That is also a very interesting question, and this is very important to know because in higher heat of vaporization was one of the main reason for higher octane number or higher resistance for the knock of the ethanol. So let's try to understand this question. So when we talk about the petrol molecules, as I have told you, that contains various hydrocarbons, mixture of hydrocarbons like octane, heptane, and isooctane. And all of these molecules are connected with the weak van der Waals forces like dispersion forces. So this is how you can see these molecules are connected with the weak van der Waals forces. And in order to break these van der Waals forces, you require very small amount of heat. Basically, in case of petrol, you require heat of vaporization is 350 kilojoule per kg only. But when we talk about the ethanol molecules, as I have already told you, that ethanol molecules contains carbon, hydrogen, and oxygen. So oxygen is the atom that is responsible for the making hydrogen bond. And this is how the ethanol molecules are connected with the hydrogen bond, right? And due to this oxygen, what happens? There is a slight partial positive charge over hydrogen and slight negative charge over the oxygen, and that is basically getting connected with the hydrogen bond. And in order to break this hydrogen bond, you require large amount of heat input, like 840 kilojoule per mole per kg. And this is the reason you require, higher heat of vaporization in case of ethanol compared to the petrol. So if you want to, see the analogies, like let's say what happens when water evaporates from your skin. So basically your skin feels cold. Why? Because the water molecules absorb some amount of heat from your body, and if it will absorb some heat from your body, obviously your body will feel cold, right? And then it gets evaporated. So because water absorbs heat from your skin to change from liquid to vapor or change from liquid to gas, that absorbs heat, that the absorbed heat is called as the latent heat of vaporization, or heat of vaporization. And the same analogy that you can put here also, if you want to break this hydrogen bond, then you require huge amount of heat. And that's why you will see that whenever you use ethanol as a fuel, so during the compression inside the ignition, I mean inside the vehicle engine, what happens? The fuel mixture will feel cold, right? And that is the reason it won't get auto ignited very easily. So that's why it will wait for some time so that the spark plug will create some ignition, and once it will create some spark ignition, then only the molecules will start burning. That is in the case of ethanol, right? So this is all about the answer of two questions: why ethanol is having high heat of vaporization, and then we have seen that why ethanol is having such a high octane number, right? So I'll stop this lecture here only. In the next class, I'll start discussion about another interesting question of this video series. That is, why does high octane number uh, fuel improves the engine efficiency, right? And that is another important question. And at the end of this next lecture, you will be able to answer this, and then you will be having a clear viewpoint regarding why ethanol can serve as a good fuel, or blending of ethanol with the petrol can serve as a good fuel, and whether there is a requirement of this engine or not. Thank you. See you in the next lecture.